Right, there was a question on 3.4. So let's talk about a straight line. Okay, y equals mx plus b, this form of a straight line. Okay, and let's talk about what these parts mean again. So m is the slope, and b is what we call the y-intercept. Okay, and we label b as 0, comma b. And the reason for that is that if it's an intercept, if we go back to what an intercept is, here we have x and y axes. Okay. If we're intercepting the x-axis, or excuse me, the y-axis, what's the x value there? Okay, well, it's a 0. Because if we're anywhere along this y-axis, x is a 0. So we call that a y-intercept. Okay, so we always label, remember it goes x, y. So when x is a 0, we have the b value. Okay, because when x is a 0 here, this term goes away and we're left with that. So let's write down an example. Y equals 2x plus 1. Okay, so first let's identify the parts. Let's identify the slope. The slope is a 2 here. Okay, and the y-intercept is a 0, comma 1. Okay, because when x is a 0, this term goes away and we're left with that number that's right there. Okay, let's build a little table. Say we're going to graph this thing. Okay, so let's choose some x values. Let's say x is a 0, x is a 1, x is a 2, x is a 3. Okay, let's figure out what y is. Well, I kind of already know the first one. Let's plug it in anyway. So we're just going to plug a 0 in for x. Okay, so we took this equation, plugged a 0 in for x. So there it is, plug the 0 in. So 2 times 0 is 0. Got the plus 1 here. Y equals 1. Okay. No surprise there. Now let's plug in a 1 for x. So y equals 2 times 1 plus 1. Follow order of operations. 2 times 1 is 2. Okay, 2 plus 1, y equals 3. Okay, so when x is a 0, y is a 1. When x is a 1, y is a 3. Let's try 2. Okay, 2 times 2 is 4. 4 plus 1, y equals 5. Okay, and let's finally plug in a 3. Y equals 2 times 3 plus 1. Y equals 6 plus 1. So y equals 7. Okay, so when x is a 0, y is a 1. When x is a 1, y is a 3. X is a 2, y is a 5. And x is a 3, y is a 7. So let's examine what's going on there. Well, the y-intercept we know, because it's always where x is a 0, and we already figured out what that was going to be right from the beginning. Okay, but we look at these steps here. We're going up by 1, so we can do this. Okay, what I mean by going up by 1 is here in the x value, we're just going up by 1 step every time. Well, the slope here, it says is a 2. Look at this. What's the difference between 1 and 3? It's 2. 3 and 5? 2. 5 and 7? 2. Okay, the slope is telling us that we're going up by 2 every single time. Okay? So let's look at a unique example. It's more like problem number 9 in your homework. Okay, just write it down while you're staring at that. So here's some data. Okay? So you can see that. So when x is a 0, y is a 2, x is a 1, y is a 5, x is a 2, y is an 8, x is a 3, y is 11. Okay, you can see it. I don't need to repeat it all. So what I want to do is I want to go from the table now, like we did, to an equation. We went the opposite way. We went from an equation to a table. So let's see if we can go the opposite direction. Well, the first thing I'm going to look for is this value right here, when x is a 0. Because when x is a 0, it tells me the y value. X is a 0, y is a 2, and remember, when we're 0, that should be our b value. So we have our b value. So if I write y equals mx plus b, well, the b value, it's a 2. So we're going to write y equals mx plus 2. Okay. Now we need the m value. Well, that's just the slope. That's how much are we changing by with each equal step. Well, look at this. From 2 to 5, what's the difference there? 3. 5 to 8, 3. 8 to 11, 3. 11 to 14, 3. Every time we're going up by 3. Well, that tells me the slope then. So I just simply plug that 3 in over here. So my line is y equals 3x plus 2.